Composite question. Composite question. Okay. So you have functions f of x equals 2x plus 3 and g of x equals 2x minus 3. Okay? Well, x is a real number. 2x plus 3, 2x minus 3. So find f of g of x and find g of f of x. Okay? So what do we do? Find them. So f of a function, composite is a function within a function within a function, okay? So f of, because f is in the normal case you have f of x, so the function f is a function of the x value, okay? In this case the function f is actually a function of the equation g of x, okay? So because f of g of x, we replace this with this, okay? So you get 2x minus 3, okay? And because that's the equation for f of x, you now substitute this into that. So you get 2 times 2x minus 3, okay? 2 times 2x minus 3 plus 3. And then you expand that out, so you get 4x, 2 times 3 is minus 6, plus 3 equals 4x minus 6 plus 3 is minus 3. So that's equal to f of g of x. And then g of f of x is a similar process, so you have g of f of x is 2x plus 3, okay? G of f of x is 2 plus 3, so g of x is, substitute this into that, so you get 2 times 2x plus 3 minus 3. Expand that out, you get 4x, so if that's 2 times 2 is 4x, 2 times 3 is 6, plus 6 minus 3, which equals 4x, 6 minus 3 is 3, okay? So this g of f of x is f of g of x is 4x minus 3, g of f of x is 4x plus 3, okay? So that's the answer to that one, and that's the answer to that one, okay? So next we are asked to work out determine the least possible value of f of times g of f of x, okay? So basically you're going to multiply these together. So we know that f of g of x equals 4x minus 3, and then multiply that by g of f of x, which is 4x plus 3. Okay? So that we found that out, which is f of g of x is this, and g of f of x is this. Okay? So we multiply these together, the usual way of multiplying brackets. So you go multiply like that. 4 times 4 is 16 x squared, 4 times 3 is 12, minus 4 times 3 is minus 12, minus 3 times 3 is 9, okay? Minus 12 plus 12 cancel to leave 16x squared minus 9, okay? But what's the least? They want to know what the least possible value of this product is. Okay, that's the product. They want to know what the least value is. The least possible value. Okay. Well, if you take x, if x is positive, okay, that means x squared is positive. So that's not going to help. I'll make this big. If x is negative, okay, x squared is still positive because the square of anything is positive. So even if x is minus 10 or minus 100 or minus 1000, this is always this is positive. So this number will be big. Okay? That will be basically greater than 0, okay? It'll be very big. If x is a million, this will be enormous, okay? A million squared is an enormous number. But if x is equal to 0, okay? X squared equals 0, okay? So if x squared equals 0, therefore 16 times 0 equals 0, okay? So that means we're left with minus 9. So when x equals 0, 0 squared is 0, 16 times 0 is 0, we're left with the function being, the product being equal to minus 9. So at x equals 0, f of g of x times g of f times x is equal to minus 9. So that's the least possible value, okay? Minus 9. That's the answer, okay? I'll do another video in composite later, another demonstration. F of x equals f of x equals x squared plus 1, g of x equals 1 minus 2x, okay? So find g of f of x and f of g of x, okay? I usually do a few examples of composites because students don't always get it the first time. So g, the function g, if you replace f of x with this, g of x squared plus 1, okay? So you're going to put this through this equation. So that goes 1 minus 2 times this, okay, which is x squared plus 1, okay? So 1 minus 2 times this, which equals 1 minus 2x squared minus 2, okay? 1 minus 2 is minus 1 minus 2x squared, okay? And f of g of x, okay? So f of the g function is 1 minus 2x, okay? And so f of 1 minus 2x, f of, putting this into what f is, x squared plus 1, you get 1 minus 2x squared plus 1, okay? So expand this all this out, you get 1 minus 2x, 1 minus 2x plus 1, okay? So expand this out the usual way, like that. 1, 2, 1, 2, okay? So you get 1 times 1 is 1, 1 times minus 2x is minus 2x, minus 2x times 1 is minus 2x, minus 2x times minus 2x plus 4x squared plus 1 at the end, okay? And then add all this up, equals 1, minus 2x is minus 4x plus 4x squared plus 1. 1 plus 1 is 2, so you get 2 minus 4x plus 4x squared, okay? So the composite g of f of x is equal to minus 1 minus 2x squared, and the composite f of g of x is equal to 2 minus 4x plus 4x squared, okay? Oh, I made a mistake. They didn't want f of g of x, they wanted g of x. Whoops, I didn't read it properly. Okay, so you got, that's correct, but it's not what they want. 1 minus 2x squared plus 1, 1 squared minus 4x, minus 2x minus 4x plus 4x squared. That's correct, but it's not what they want. What they want is g of x, okay? I made a silly mistake. So g of x is equal to 1 minus 2x, so g of 1 minus 2x, okay? So then you put this back into g of x, so g of x equals 1 minus 2 of x, so you get 1 minus 2 times 1 minus 2x, okay? So then 1 minus 2 plus 4x, okay, equals minus 1 minus plus 4x, okay? Minus 1 plus 4x, okay? So that's g of x, okay? So yeah, that's how composite works. That's what they want. This is correct, but that's not what they actually wanted me to do. That's what they wanted me to do, okay? So I hope that's clear.